Okay, YouTube, in this video we're going to be looking at what we call the horizontal line test. And in math, the horizontal line test is a test to see whether or not the inverse of a function is also a function. And so let's go ahead and list that here. We say it's a test to see if f inverse is also a function. And so what we're going to do here is we're going to write the definition of a function first and foremost, just kind of a review here. But we say a function in math is a relation between a set of inputs, we usually call these x values, with a set of outputs. We usually call these y values, in which every input, or x, goes to one and only one y value or output. Okay, and so basically what we're saying here is that if you are a function, then every x value that we plug into you, you're only going to get one y value out of you. Okay, and so what would that look like in terms of just a graph that is a function here? Well, what I've done was I went and I graphed y equals 2x minus 1. And what I know is if I were to make a table of this, you would see that every x value that I plug in is only ever going to go to one y value, because every time I plug in a new x value, we're going to double it and then take away 1 if the rule is 2 times the x value minus 1. So what would this look like graphically? Well, recall that if it is a function to begin with, then every x value goes to only one y value. That would mean like -2 went to -5 here. -1 x value goes to -3. 0 goes to -1. Basically, everywhere on our graph we see a y value, we would say that every x value only went to one y value. And so a test that we typically run here is called the vertical line test. And I'm just going to create a random vertical line here. X equals, let's do this, x equals number n. Let's see if it'll let me put in a slider. Let's do this, n. It doesn't want to let me put in a slider here, you guys. And so let's at least do this. If I said x equals 3, maybe it'll let me put in one now. Essentially, what you can see is that a vertical line would be a good representation of a single x value, because we could say, well, it's going through absolutely one x value at that point. But what we're looking for here with the vertical line test would be to see, hey, is there anywhere that a vertical line would hit our graph more than once? Because if we had a vertical line hitting our graph more than once, then that would mean that we had an x value that went to two separate outputs. And so we could see that this purple graph is a function because it passes the vertical line test, or we could see that every x value goes to only one y value. Now the neat thing about inverses, and of course we've been seeing this happen, is that we see that inverse functions have graphs that are reflected about the line y equals x, or in other words, y equals mx plus b. We would see that this has an intercept of 0 and a slope of 1. So rises 1, runs 1, rises 1, runs 1. We know that every point on our original function here, things like 2, 3, 1, 1, 0, 1, these points right here essentially would be flipped domain and range if we found the inverse. And so what I've typed in is we started with y equals 2x minus 1. I'll flip my domain and range, and I'll make it, instead of y equals 2x minus 1, we'll make it x equals 2y minus 1. And what I get is this graph right here. And so what I want you to see is that that second graph that's in black there also passes the vertical line test, or that is, every x value on this graph here is only ever going to one y value on our graph. So the question in this video is, would there have been a way that I could have looked at the original function, this y equals 2x minus 1, and told you that its inverse is going to pass the vertical line test? And absolutely there is a way that we can do this. We can use what's called the horizontal line test. And so because we know that if a graph of a function, okay, is 1 to 1, then it passes a vertical line test. Well, I know that if I were to actually draw the inverse of this function here, I know it would be reflected about this line y equals x. It would look something like this here. And so I'm just kind of giving you a rough sketch. It would look like this. But we could see that this graph here, the purple graph, would pass the vertical line test. But the reason why I can tell you this is because the original function would have passed what we call the horizontal line test. So if it passes a horizontal line test to begin with, then when you do go find its inverse is definitely going to pass a vertical line test. And so the horizontal line test is just a test to see on our original function, is our inverse also a function? So let's read this together. We say that the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. And so we could see that with this right here, we could see that its inverse would be a function also, but because its original graph, I could never draw a horizontal line anywhere where it would hit my graph more than once. Now, when you look at this function right here, this looks like our parent function of a quadratic. It's definitely a function because its original function passes what we call the vertical line test. But when you look at, will its inverse be a function? That graph that I would get if I were to reflect it over this way, we could see that this graph here would clearly fail a vertical line test. But the way I would be able to tell you that is because, well, it doesn't pass the horizontal line test with f to begin with. And so f inverse is not a function. And so what we're going to do is this. We're going to consider this function here, f, that we're given. It looks like a square root function, 3 times the square root of x plus 4. And we want to determine whether the inverse of f is a function and then find the inverse. Well, knowing that this is a square root graph, and knowing that square root graphs, at least the parent function, y equals the square root of x, starts at 0, 0, goes through 1, 1, goes through, we'll call this 4, 2, but looks like this, okay? Because this is going to pass a horizontal line test. That is, I'm never going to be able to draw a horizontal line anywhere where it hits it more than once. Then what I'm going to tell you is that f inverse must be a function because f passes the vertical or the horizontal line test, the horizontal line test. And that's what we did where we're just checking to see, hey, would a horizontal line hit this more than once? Because it doesn't, then that means that f inverse is a function and we should be able to find it. So now what I want to do is determine whether, well, not determine whether it's a function, but actually go find the inverse. So let's go ahead and start with this. We say f of x is equal to 3 times the square root of x plus 4. So the very first thing we want to do is we're going to replace our f of x with y, just so that we have x's and y's. And of course, to get the inverse then, what we're going to do is we're going to switch our domain and range. We're going to switch all of our x and y values here. And so our x would go in where we had a y before, and our y would go in where we had an x before. We say, well, then our inverse function looks like this. Now what we want to do is isolate the y value. So this means that we're going to have to perform some algebraic steps here to get that by itself. We would say x minus 4 is equal to 3 times the square root of y. Now we're going to divide both sides by 3. And so I would get x minus 4 over 3 is equal to the square root of y. The only thing we have left to do then would be to square both sides of this here. And so to square this, we would get rid of the root here. We would say that this new function would be x minus 4 over 3 squared, and that would be equal to y, or what we're going to call f inverse of x. Now I do want to simplify this just because I can. So that would mean that we'd have to take everything on the top to the second over everything on the bottom to the second using our rules of exponents. And on top here we would have to actually FOIL this out, x minus 4 times x minus 4. On bottom, when we do 3 squared, we just get 9. And so going ahead and FOILing on the top, I get x times x, minus 4x would be minus 8x, and then negative 4 times a negative 4 is a 16. Here's what we would get for our inverse function. So of course, we would want to, okay, go ahead and express this as, let me fix this equal sign here, f inverse of x. And this, of course, would also be a function because the original function passed the horizontal line test. So in the future, when we want to assess the situation and say, well, would it even have an inverse function, we'll look at its graph of the original function and say, would it pass the horizontal line test? Because if it passes the horizontal line test, and that is if no horizontal line intersects the graph at more than one point, then we would say that its inverse must exist. Cheers.